This is Birhan Osmanoğlu, and in this video I'm going to demonstrate you the installation and the usage of the software program that we have developed for MA 557 Metal Cutting Principles course, whose instructor is Professor Dr. Ömer Akanlı. This application was prepared by Birhan Osmanoğlu and Ufuk Dirmencioğlu. So let's start off with the installation. Whenever you download the MA 557 Additive Manufacturing Project zipped file, first thing to do is right-clicking on it and selecting Extract Here option. When extracted, go into the file. You should see three objects: the project report, the project presentation, and the file which contains the executable software program within it. Go into the file which is named STL Slicer G-Code Gen app. To run the program, there are two options. If you don't have MATLAB 2020B installed on your computer, you should go into for redistribution and install the program using this installer. In order to run the program afterwards, you should also have to download MATLAB compiler 9.9, which is a license-free product that you can download from mathworks.com. Since I have MATLAB 2020B installed on my computer, I will go into for testing file, and within that file there is an executable file called Additive Manufacturing App STL Slicer G-Code Generator. I will double click on that executable file in order to run the application. The application should be opened in a few seconds. It has opened. So let's go on with how to use the program. In order to generate the G-code for the particular file that you want to generate G-code for, the first thing you have to do is load the file into the program. To the upper right corner of the software, you should see the file browsing features. Go into Browse Computer and select the particular STL file that you want to generate G-code for. I will go into my computer and find an example STL file. Let's select Cobra Attack Helicopter 1 STL file. Whenever I select it, I should also click Open File button in order to load the STL file into my program. As you can see in the middle, the attack helicopter is loaded into our program. Let's rotate it in order to change its orientation. Yes, we have rotated it. You can change the printing parameters and slice height, and then you can generate the G-code with respect to these parameters. Let the slice height be 0.2 millimeters. We have already changed the orientation by rotating it along x-axis few times with the angle of 90 degrees. Let's change printer parameters from the left hand side of the application. Within that gray box, there are many parameters that you can adjust. Let the bed height be 250 millimeters, bed width be 200 millimeters, temperature, nozzle diameter, filament diameter, and filament temperature, let these stay as is. And on the page 2, you can change the shell thickness to 0.2 millimeters, for example. Let the other thickness stay as is, and infill density 25%, which is okay. Let the printing be equal thickness rather than adaptive printing. So in order to generate G-code for these adjustments, I should click on that Generate G-code button, which is colored red. I can name my G-code as Heli2 G-code. Whenever I click Generate G-code, a pop-up should appear telling me that G-code was successfully generated and saved. The G-code is immediately placed in the file that your executable file is located in. So in for testing file, you can see a G-code named Heli2 has appeared. This G-code, as you can see, can be put into 3D printers in order to print this particular object. There is one more feature which allows us to visualize how the layers will look like, how the printer will move along in order to print this object, which can be activated by clicking on Run STL Slicer part. However, if the objects we are dealing with are complex, this process may take up to few hours. For the demonstration purposes, we have already done it before, so I'm just going to show you the image of how the slices will look like instead of waiting for a long time during the video. Here is a screenshot of our program where we have sliced the helicopter in order to see how the slices will look like. As you can see to the right hand side within the plot, the red figures are layer by layer slices that the printer makes, and they were done in an order with respect to the printer's movements. However, in order to generate G-code, you don't have to wait that much. The program actually generates the path that printer has to move along within seconds. However, just visualizing of this process takes some time due to the restrictions of MATLAB. Let's close this figure. And for the demonstration purposes, let's select the rather simple figure and run the STL Slicer on video as well. I'm going to go to my STL file again and select a simple rectangular piece. As you can see here, it's a simple rectangular piece which is approximately 100 millimeters long, actually longer than 100 millimeters. You can adjust the printer and slice parameters from gray parts like I've already said. Let the bed height be 400 millimeters this time and bed width be 300 millimeters. You can change the bed temperature to 65 degrees Celsius this time, just to show how the program works. Shell thickness be 1.0 millimeters this time, and let it be adaptive thickness rather than equal thickness. Let the slice height be 0.2. Let's run the STL Slicer. This STL Slicer shows us how the printer will move in order to print that object and how the slices will look like. Since this is a simple rectangular object, its slices will be very simple and it was generated within seconds. Let's generate the G-code for this as well. Let's name it as simple.G-code. Whenever I click generate G-code, again a G-code will be immediately placed in the file that our application is located in. It should be in here, here, and for testing. This is where my application is located in. So here, as you can see, there is a G-code named simple.G-code. Let's look at it. I can load this G-code into my 3D printer and have this object printed. This was a quick video on installation and usage of the software. Thanks for watching.